The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is building big data capabilities, opportunities and challenges. Our guest speaker today is Srinivasan Govindaraj, Senior Director and Practice Head, Enterprise Information Management. He is Senior Director and Practice Head from Enterprise Information Management at Virtusa, a well-known information technology service provider with a global reach. He possesses more than 25 years of experience in business and technology consulting and building global practices in the field of business intelligence, analytics, and corporate performance management. He is a recognized thought leader in the field of big data and analytics and has held several leadership positions in large IT services companies. So without further delay, I introduce you all to our guest speaker. Over to you, Srini.
Thanks, Aradhana. Good evening, everyone. I'm very glad to meet all of you through this medium and share my thoughts on building big data capabilities, the opportunities and challenges. This is a presentation covering broadly the theme of competencies in big data and how one can develop that both from an enterprise and individual perspective. So I'm going to take about 45 minutes for my presentations and then open it up for your questions. So broadly, the agenda that I'm going to cover today is to provide an overview of big data to set the context. Most of you will have some preliminary understanding of what big data is all about. I'm just going to give you a quick recap of the basic ideas behind big data, why is it becoming prominent and so on. And then one of the questions that uppermost in the minds of many people is how does big data coexist with data warehousing and the traditional data management world. So I'm going to spend some time discussing about that and then get down into the trends and opportunities from big data, both from a market perspective and from a competency perspective. So then we will get down to the main topic of what we're going to discuss today, which is about the challenges in competency. So let me emphasize at the beginning that this is not a technology presentation, so I'm not going to get into details of what technologies you need to master. Rather, I'm going to give you a bird's eye view of the various kinds of technology components plus business insights that one need to have to manage a big data project. So with this overview, so let me get on to my presentation. So as I said, I'm going to start with a quick understanding of what big data is all about. So the first thing that we are all aware is that there's a deluge of data today. And before I finish this presentation, so many things would have happened in the big data space. So many websites getting created, hundreds of thousands of apps downloads, and millions of search queries, and so much of activity on Facebook, and a lot of messages getting transmitted. So which is all a part of a good thing as far as the social media is concerned. So a lot of structured and unstructured data will be generated and shared during this period. It's not just data that is getting shared. We also know that there will be a lot of economic value that is generated out of all this. So by the time I finish this presentation, millions of worth of goods would have been exchanged over the e-market, so generating a lot of revenue. So there is an economic side to all this immense amount of transactions that happen. So I'm moving on to my next slide. So this is about what exactly is big data. It means, I know it means many things for many people. So people understand it in different ways. For some, it means that we are looking at a vaster scope of information. So then what we were doing earlier, it's a new kind of data and analysis. It's all about getting information on a real-time basis that we need it as and when we want it. So as transactions happen, we capture immediately and look at it. and we are deploying a wide variety of new technologies to get data. So there's a lot of data influx from new technologies and non-traditional form of media. I mean, as I just said, there is a lot of deluge of data from the social media. So there's a lot of data that we get from LinkedIn or Facebook or Twitter, which organizations are trying to integrate into the traditional sources of data. And we are also looking at very large volume of data, where terabytes were considered very large. Today we are talking about petabytes, exabytes. So definitely a large volume of data, both at the individual level and at the enterprise level that we are handling. For some, they think that it's the latest buzzword or data warehousing coming in a different avatar. So, and for some, it's all about social media data. So the good news is big data is all this and much more. I mean, each one is looking at one aspect of big data. So it's definitely right that we are looking at all these things. But what we need to do is to integrate all this into some kind of a technical as well as a working definition of big data, which is what I will do in the first few slides before I get down into more details of how we can approach and analyze big data. So I'm moving on to my next slide, which is a more definition-oriented slide. We all know that a subject like big data, which has many different dimensions, is very difficult to define. One can only describe it in a very wide term. So I'm just taking some of these definitions which are available in the market today. So what are the definitions given by industry analysts such as Gartner or Forrester, or leading technology firms like IBM or Oracle, which are very active in the big data space? So one thing, if you look at in the definitions that you see here, so the theme is that we are dealing with variety, volume, and velocity. That is, we're dealing with a large amount of data. We are dealing with data that is coming in different kinds of structures, unstructured, semi-structured, and structured. And we are dealing with data which is coming in at a very high velocity, which means a lot of real-time data, a lot of data that is streaming in at you. So this combination of data, which has all these dimensions, and IBM has added a fourth dimension, which they call as veracity, because we are also concerned about what is the quality of data that is coming in, how clearly it is defined, and things like this. So if you put all these four things together, so we have these four dimensions which converge to define and distinguish the use of big data. So the other way to look at it is that we are looking at the ability of an organization to store, process, and access all the data that it needs. Here the emphasis is on the term all the data that it needs, which means that we are not ignoring any kind of data, that we are not throwing away any kind of data, but rather we are interested in collecting as much as we can without making any value judgments on whether the data will be useful or not. So that's another way of looking at big data, where the concern on data warehousing and data management in all these days has been about structuring data, cleaning it up, taking a smaller set of data, putting it in one repository. So big data is kind of totally going against that kind of a thinking, saying that let's not ignore any data. Let's try to get all that we can into our into that enterprise. So this is the definition of big data from a market and industry perspective. But I wanted to start my presentation with the more working definition, which captures the essence of big data and which allows us to look at it from competency dimensions. So I'm moving on to my next slide, which is giving you the working definition of big data. So it's a very simple definition. So here we are saying that big data is about understanding the relations among diverse pieces of information that were typically considered difficult to capture and analyze in the data warehouse era. So in a sense, we are actually allowing the data to speak to us. So that's why industry experts talk about letting the data speak to you, which means many things, of course. The fact that we can get data, the fact that we can analyze it, the fact that we can sense what is happening within the data set, and things like this. So this is a more operational or a working definition of big data, which gives us an understanding of the kind of competencies that's required. So I'm going to get into details of what kind of capabilities and competencies are required based on this kind of a definition, which is about understanding the relations within that information that we are collecting. So moving on to my next slide, which is a very important slide here. Basically, I'm talking about the change in the mindset that's required for big data. This is very key as far as the competency is concerned. that we are talking about three major paradigm shifts as far as understanding data is concerned. One is that at an enterprise level, we are ready to analyze vast amounts of data rather than settle for very smaller sets. So that means no longer are we interested in sampling, worrying about what's the size of data that we need to have. We are more worried about what kind of information that we need to get rather than worrying about how much we can store. So at an enterprise level, we should be ready to analyze vast amounts of data, which means making all the technology investments that's required, making all the infrastructure investments that's required. So that's one mind shift that we're talking about, that we are ready to take on large volume of data. The second major mind shift that we are talking about is embracing real world messiness of the data. So what I mean by this is, earlier we were discarding many kinds of information, saying that this is not structured. We were not able to handle semi-structured or unstructured data, and therefore we were ignoring that. Today we are saying that that's a kind of data precisely which is very important, and therefore we will go after that data which may not be structured now, which will be in a very crude form. It could be totally unstructured, it could be very real time, but it could come to us in a very messy way. The data quality may be very poor, but we are not worried about that. We are not looking for exact data. We are looking at all the data that could be available. It could be the sentiment of a customer. It could be the change in behavior of the customer. It could be the change in mood of a customer. So these are the things that we are looking at. So that is one mindset change that we are talking about. And the third mindset change, which is very important, is that we are looking at correlations and not causal explanations. Now statisticians understand this. They say that it's, we are all familiar with the term root cause analysis. So most of the time we say that business intelligence is all about finding out what is the root cause for some problem. But in real world, we know that finding out the root cause for something is very difficult. So instead of seeking for cause and effect explanations, which has been the predominant way of business intelligence, drilling down into things, looking at cause and effect explanations, here we are looking at what are all the things which are correlated. I don't know at this time whether it in a particular correlation that I'm looking at, whether it has a causal explanation. But all that I need to know, if I make, if in one customer profile, if there is one change at one end, does it create another change? Or two different profiles of customers, are they doing the same thing at this point of time? If somebody buys a book of A, is a different customer buying the same book A, but with a different profile. So we are looking at correlations in product purchases. We are looking at correlations in the way, say, credit cards are being used. We are looking at correlations in basically customer behavior, right? So we are interested in those correlations rather than causal explanations. So if you look at all these three mindset changes that's required, that defines the context for big data. And that in a way is a revolution that is actually transforming how we live and work. So this gives you an idea of the kind of competency changes that one needs to make. So we are not looking at big data as a pure technical problem. We are not looking at it as a pure business problem, but we are looking at it as a combination of all these things based on this kind of a context that we are looking at. So what exactly does organizations have to do? So here I am mapping out certain stages in evolution in terms of big data as far as organizations are concerned. So big data implies big transformation as far as organizations are concerned. And today organizations are not doing big data just to make some incremental changes. They are using it to make some fundamental changes in the way they manage their customers, fundamental changes in the way they deal with the channels, and how they operate their internal operations, and how they work on their processes. So all, of course, everything begins with the end user. So here we are looking at the driving factor for companies is that we want to offer enhanced customer experience via web and mobile technologies leveraging big data. So it's a different kind of a customer experience that we want to give based on a digitization platform, and the idea is that big data will be driving this. So this is one of the biggest business drivers as far as big data is concerned, that companies are concerned about the experience that their customers are having and desirous of making that experience a very enriched kind of a one. So we want to predict end user behavior and delight them with what I call the next best offer. I mean, can I provide the right product to the customer at the right time? Not go back to the table, redesign the product and then tell the customer this is what I can give. Can I provide to the customer a right product even as I am having the conversation with them? So this is what today predicting end user behavior is all about. So and that's possible through big data. So every big data exercise begins with the end user. So this is the first stage of the evolution that we're talking about. The second stage that I'm highlighting here is the fact that big data is again all about data. So while we are looking at business problem, at the same time we are trying to find answers to business problems through data, and therefore companies have to do a lot of work in terms of building the proof of concepts and the prototypes to evangelize big data within the organization. And the big data application is not independent of your data warehousing and BA infrastructure. It's very much a part of it. It's very much complementary to what we already have. So we are not throwing away what we have already within data warehousing and business intelligence, but we are building upon it. The third stage in the evolution of big data within an organization is all about transforming what we are doing. So there are a lot of specific solutions based on big data. I highlighted healthcare and insurance, but it's true in all other domains, be it bank or be it an insurance company or be it any financial service organization. At the end of the day, all that we are doing in big data is to gain the analytics advantage. So big data actually comes to life. We are unlocking the value in big data mainly through analytics. So advanced analytics is focused on customer-centric outcomes, and therefore when we combine big data and analytics, so we have an enterprise-wide footprint for improved decision quality. So all along in the earlier era of data warehousing and business intelligence, there was always a concern that we are improving information quality, but it's not getting translated to decision quality, right? We are still providing the right information, but we are not sure whether our end users are taking the right decisions at the right time based on this information that's available. So this gap is what big data and analytics is planning to bridge. So having set this context, let me move on to finer details of what we can do within big data. I hope you can all see this slide. I'm on slide number 9 on big data management, on the question of how organizations are dealing with big data. So one of the things that commonly everyone understands is that when we are talking about big data, we are talking about multitude of sources, that we are not talking about a single source, we're talking about many sources of data coming together, which is right. So what exactly is happening in the industry today? In terms of big data applications, structured data is still prominent. As I said earlier, we are not throwing away whatever data acquisition and data management infrastructure we have in place. So there's a lot of scope for managing relational data. The structured data size will be now quite large, but that's very prominent. That's very much part of your big data applications. At the next level, semi-structured data is widely used. So we know that data will come to us in combinations of many things. It could be as many event kind of data, many hierarchies, and along with your relational data. And there are a lot of standards now like XML or JSON and RSS, which is covering this kind of semi-structured data. So that's a widely used format as far as big data applications are concerned. The third interesting aspect is that social media data is managed very actively. As I showed you at the beginning of my presentation, there's a deluge of social media data, and companies have to manage that very actively. And though this is a relatively new source of data, it's getting, the importance of social media data within big data is quite high. So much so that many people associate big data with social media analytics. And the next aspect is unstructured data, which is as of now slightly low compared to the use of structured and semi-structured data, but it's beginning to gain importance. So this could be a lot of your textual data, and this is where companies can mine a lot of information about the opinions, about the sentiments, about the moods of customers. And so that's definitely beginning to gain importance, and with especially a lot of advances in areas like natural language processing. And apart from this, companies are today leveraging on your geospatial, sensor, and machine data. They have definitely arrived. So there's a lot of analysis of this kind of data and connected to your regular structured data. Web applications have been existing for a long time. So web data is a common source of big data. So one can look at your web logs, clickstream data to understand how customers are behaving. So what kind of product combinations they are buying, and what is kind of attracting them, or what is making them drop certain things and things like this. So there's a lot of wealth of information that can be obtained from your clickstream data. So this is what organizations are doing as far as big data is concerned. The technology that we use is the material here. So what is important is that we look at this variety of sources and see how we can make use of them. So we need to now look at, okay, having doing all this, I mean, what is the end result as far as organizations are concerned? As I said, we are starting with business outcomes, and therefore we need to see what is the end result of all these big data initiatives. So we all know that it brings in immense value to the organization across all domains. So I listed out a few domains. I mean, it can be applied to any domain, irrespective of the size or the customer intensity and things like that. So at the very first outcome that we are looking at is, can I predict and understand customer behavior in a better manner? So this is one question that big data addresses head on and provides answers. So we are trying to recognize sales and marketing opportunities. We are trying to see if we can do very fine segmentation of our customer base. So where a particular company, let's say, has defined its customer segments into, let's say, 10 different segments. Now big data can enable that to be multiplied by 10 times and have 100 different segments of the same customer base. So that's the kind of value that we're talking about. And of course, fraud detection. Fraud detection has been there for quite some time, but now with big data we are seeing whether that fraud detection score, the likelihood of fraud score can be enhanced as far as, let's say, an insurance company is concerned. And targeted social influencer marketing. So as I said, social media data is available in plenty, and that's one area big data has made a lot of inroads into analyzing. And so we know with the social media data that we can do targeted marketing. We know who are the social influencers based on the social media activity, and therefore we can target them. Quantification of risks, which is again associated with aspects like fraud detection, that we can do a finer segmentation. We can quantify the risks in a lot better way. So we can build a better risk profile of customers based on the fine segmentation that we can do. So if you look at all these problems and areas are nothing new. They've been there for quite a long time. They've been the scope of many quantitative techniques. But today, with the availability of big data, they're all taking a different dimension. So basically, our prediction of customer behavior is increasing. Our segmentation opportunities are increasing. Fraud detection is improving in efficiency and effectiveness. So this is a kind of what we are seeing in big data, is that the change in mindset is bringing about a new kind of benefits in the existing areas. So I'm taking on the question now of how is big data different from the traditional data management that you have been doing all along, because that one question will be uppermost in everyone's mind today, saying that, okay, one can understand that big data is bringing in all these benefits, but what were we doing in the earlier era when we were collecting still a lot of data? We were putting it into some storage in some repository. So what were we doing with that kind of an approach? So here we're trying to compare these two different approaches. So what you see on top is the classic enterprise data warehouse method, which means a classic way of storing data in various central repositories. So here it followed the traditional model of the business users determining what questions to ask and saying this is the kind of analysis that we want to do, and then the data warehouse architects went after the kind of source of data that's required for analysis, and then IT structured those questions that could be answered. So here the emphasis on, we want to capture only what is needed based on the questions that have been asked. So it was a more a restricted kind of an approach, and also it fitted in those days when there was a lot of cost associated with storage, there was a lot of problems associated with collecting data, and therefore it was more of a filtering and funneling kind of an approach. Now, if we look at what I am describing in the bottom layer, which is the big data method, and here we have reversed the whole thing. I mean, here we are not starting with the business questions. Here IT is delivering a platform for storing, refining, and analyzing all the data sources. Now IT is saying, I have no problem with collecting any kind of data, whatever be the type of structure, that I am ready to collect it. So, and I don't know whether you need it now or not, but in any point of time, if your business needs that, it's available. So we are delivering a platform because storage costs have gone down, transaction costs have gone down, that we have the ability to analyze any kind of data. So I'm building the platform, and now business is able to explore the data and find a lot of answers to the questions that they didn't have earlier, but now they know that these are the questions worth asking because the data is available. So these are looks like two different kind of an approach, fundamentally different kind of an approach, but the interesting fact is that they are actually coming together. So many organizations are today building what I call as a big data EDW, big data integrated ecosystem, which allows one to have a data warehouse for certain kind of analysis, but build a big data platform to ensure that the business is able to analyze it the way they want. So this is a change that we are seeing from the traditional data management to the new world of big data. I'm moving on to the next slide to show, to delve further on this topic of how big data and the enterprise data warehouse can coexist and complement each other. So here I'm listing a table where I'm saying that enterprise data warehouse still makes sense as far as certain aspects are concerned. For example, if we are worried about high quality, consistent data or data governance or extensive security and compliance, so we are not looking at big data here, we are looking at what can come out of the data warehouse. For example, let's take a simple thing like a bank is maintaining checking accounts for many customers. So we want the answer to what is the balance of a particular customer asking a question like what is the balance that I have in my account. So the answer to that has to be absolutely consistent. I mean, you can't give different answers at different points of time or from different places. So earlier I talked about big data accepts messiness, but in certain cases messiness and poor quality of data is not acceptable at all, and there we have to rely on enterprise data warehouses. So to summarize, we leverage traditional EDW systems for answering the known questions. And so that's a point that we're trying to make, but we are deploying big data in unknown areas for advanced analytics. So that's a trend that we are seeing. So this actually makes my point that both data warehouse and big data coexist and complement each other. So what are the trends that we are seeing? I'm on slide number 13, which is talking about the kind of things that have happened so far and what can we expect as we move forward into the coming years. So we have seen so far that integrated enterprise data warehouse plus Hadoop plus data visualization, so that has been the norm. We have seen a lot of social media analytics and of course predictive analytics, which is the end result of all this big data work that we do. So in areas like customer behavior, fraud detection and claims and things like that. So this is what we have been seeing so far, and in future we'll see more of these integrated ecosystems. We will see in-memory computing goes mainstream, which means now compiling reports will become much more easier. Users will be able to develop reports based on their needs without going in for big repositories. So we will have big data analytics on cloud, making it a lot more accessible, easier for people. And we will have new sources of big data. So I've been talking about a lot of different kinds of sources of data. So we will also have now a lot of machine data, and we will have, especially with the growth of Internet of Things, so we will have a lot of sensor data and machine data coming in. And from an analytics perspective, so one can see a lot of advanced analytics, natural language processing, geospatial, integrating voice and video data into the regular, structured data format. So basically, the emphasis will be on providing accelerated business outcomes and building a connected world through all these changes happening in the big data space. So very exciting time for people involved in this space, whether purely from technology perspective or purely from business perspective. It's going to mean quite a lot of things as far as enterprises are concerned. So to summarize what I have been talking about so far, so big data definitely means big opportunity because the technology is there today which will enable us to make sense out of all available data. So there's tremendous amount of noise that's there in the market. So one has to differentiate the noise from the signal. I feel that big data is all about improving the signal to noise ratio. And in this process, I feel thousands of jobs, new roles are getting created. And people understand now that big data is not a mere technology issue, but it's almost a social phenomenon which is actually changing enterprises, the way they think and behave. Just to give you some quick statistics, I am on slide 15 to give you a kind of view of the market of big data. This is based on a couple of sources which I lifted in the slide. Listed here. So we're talking about a combined market of $10 billion of big data market. So both if you put together the software as well as the services aspect. So you can see here that's a very healthy growth rate. And this is rather, I would say, in a way, this is a conservative estimate. There are estimates which is talking that big data is close to about $50 billion worth of business as far as software and services are concerned. So, but the interesting fact is that while the opportunities are growing, what we are worried about is the talent shortage. So I'm on slide 16, which is giving you some figures about the kind of shortage that we're looking at. So everybody is in agreement that big data is growing, its importance is growing, the technologies are available. But what is going to be our biggest constraint is the fact that enough people will not be available to understand this big data, to work on big data, to manage big data, and to get meaningful results out of that. So if you look at the talent gap, which is actually for the US market, but it's applicable at the global level, the figures are similar. So we're talking about in the US market a gap of about 200,000 professionals with deep analytics expertise required. So here I'm talking about people with a lot of in-depth analytics expertise. So there is an equal number of people required as far as the technology surrounding that are concerned. And on the business side, we are talking about a gap of about 1.5 million data savvy managers who will be able to consume the results of big data and use that to improve their business processes and business outcomes. So this is the biggest challenge that the big data world is facing today. Is how are we going to bridge this gap in terms of this talent gap, both in the technology, analytics, as well as in the business side. So in this short time frame, it's very difficult for me to completely talk about how we can address this. So in the subsequent slides, I'll just quickly go through some of the key points that I have in terms of what are these competencies that we're talking about and what can one do to launch a competency journey in this big data world. So I'm on slide 17, so where I'm talking about the convergence of various technologies and disciplines. So I've been talking about big data so far. So one of the interesting things is in today's world, the coming together of cloud, mobility, social data and analytics, throwing up a lot of big data opportunities. So we are looking at all these different technologies in these 4 different domains, and we are also looking at the growth in predictive modeling and statistical modeling kind of work. So the big data opportunities are basically transforming 3 things. One is creating a new culture. It's enabling a data-driven culture, a culture where decisions are based on data, and as well as the intuition that comes from big data. And we're talking about transforming businesses because now we know that we can understand customers better, we can design products and services better. And then third, of course, we can optimize our technology investments because we know what's the kind of data that we need to go after. We know what is the best way to put together the various sources and create a big data infrastructure. So these are the things that are driving big data, the coming together of these technologies and disciplines. So I'm moving on to my next slide. So I'm trying to build on whatever I have covered so far to give you a perspective on what analysts can do. I mean, what we as analysts looking at various aspects of big data. So what is it that we can do from a competency building perspective? So at a broad level, we can classify all the analysts into 3 kind of categories. So there's a vast majority of people who can be called as analytical amateurs. I mean, I'm one of them. So 70% of the people are in this. So basically, we can comfortably use spreadsheets. We know how to compare data. We know how to look at trend, and we know how to do. We can do trend analysis. So to a certain extent, we know what we can do as far as correlation is concerned. So that's a vast majority of people whom I call as analytical amateurs. And the next level, so is what we call as analytical professionals. People who can use visual tools. They know how to visualize data, how to present it, and who are comfortable in developing basic models, which will allow you to analyze this, this vast amount of information that's available. At the highest level, the analytical expert level is where the biggest challenges today lie in terms of competencies. So these are the people who can actually create algorithms, who know what kind of decision problems exist and what kind of new solutions we can provide from big data. So that's the kind of challenge that we're talking about. So we have shortages both in analytical professionals and analytical experts. So at a high level, this is about the kind of competency challenges that we have, but we can break it down into more technology specialization and business domain perspective. So which is the theme of discussion in my subsequent slides. So here I'm going to give you a very quick list of some of the things that we are looking at. So one, we know that big data brings new and exciting roles and opportunities. So we have new roles like Chief Analytics Officer. There are roles like data scientists, which is a very unique breed of people who know statistics, who know machine learning, who know computer programming, who will know the big data technologies and also the business problems. So it's a very difficult combination. But there are people who can who claim to be data scientists, and that's a very rare breed of people. So we have big data architect. So we have moved away from the earlier era of ETL architects. So we are now having big data architects who can understand the various types of data that I was talking about, semi-structured to unstructured and structured and geospatial and all that. So these are the people who can understand all these different sources of data, different types of data, and have a plan to put them together. And then on the visualization side, so there are roles which one may call as data visualizer. And since data has importance here, so data governance is quite important. So we will have data stewards who know where the data comes from, who will own the data, how the data needs to be defined, and things like that. And of course, we from a statistical perspective, we will have statistical modelers, quantitative analysts who are comfortable with building algorithms, developing newer models for analyzing data. And then of course the machine learning expert, because big data is all about automation and algorithm. So we need a lot of people who understand natural language processing. We have to have people who are comfortable with techniques like neural networking and things like this. So if you look at these roles, a wide variety of roles, some which is purely data oriented, some which is purely statistics oriented, and there are roles which is integrating all of them and connecting it with business. So this is a kind of menu that we are looking at as far as the roles are concerned. But typically, I'm moving on to the next slide where I'm trying to give, while that earlier list may look daunting, so I'm just trying to make it simpler by saying a typical big data team in an organization can have, basically 6 kind of roles. One is the architects, and then of course the domain experts or the subject matter experts, and then we have the analysts who will be able to bring in your data analysis and statistical analysis kind of experience into the picture. And then we have the technical administrators who know how to manage large sets of data, and then we have an application specialist. So I have called the project manager as a DWBA project manager simply for the fact that we don't have a big data project manager. So the big data project manager has to come from the data warehousing and business intelligence background. So essentially what we have here is a project manager with this kind of a team composition. So one can break this down into further roles, but broadly if you have to take a career path in big data, so this is one of the roles that you will be looking at. So I'm moving on to the next slide, so which is about the scope of analytics. So we have talked quite a lot about the predictive modeling and statistical analysis. I just wanted to give a quick overview of what are the things that one is looking at. So starting with basic questions like why is this happening? So that's one question the analyst will be asking. So what will happen if these trends continue? So that's a second kind of question that one can ask. The third question is what will happen next? So that's all about predictive modeling. And the fourth aspect is about optimization, where we are asking the question as to what's the best that can happen. So within big data, so all these questions get answered. So when I say we are bringing in a big data analyst or a big data expert, it should be someone who is comfortable with all these kind of questions. So again, to look at the typical concerns of a big data analyst and data scientist, I am on slide number 22. So where I am just showing the kind of questions that somebody who's into this, getting into the details of a project will be worried about. He has to be worried about how to predict behaviors and derive the sentiments of customers, how to process unstructured data, how to correlate different sets of data, so how to identify new patterns from the untapped data. So these are the kind of questions that the big data analyst or the data scientist will be asking. So the answers are not easy to some of them. So you will have to bring together a wide variety of technologies, a wide variety of approaches which are available, but you need to understand them and bring them together to answer these questions. So I just want to quickly talk about the scope of analytics problems, since I spent some time on analytical modeling and statistical modeling. So fundamentally, there are only three kinds of decision problems that one is looking at. One is the classification problem, where we are trying to let's say develop a profile of customers, right? So this is a typical classification problem. So to give a specific example, if one were to develop a profile to differentiate female and male stroke victims, so this is a simple classification problem. So this is very useful as far as customer profiling is concerned, customer segmentation is concerned, to define something like who is the most appropriate customer for my campaign. So that's a classification problem that we're looking at. The second kind of problem that we are looking at is how to estimate something. It could be estimating the price of something, it could be estimating the stock price, it could be estimating the income of a person so who owns a sports car. So this is a very classical statistics problem. And the third kind of classical problem is around prediction. So can I determine if a credit card customer will respond to the offer of a marketing campaign? So if you put these three kind of problems together, classification and estimation and prediction, so we are entering into the world of statistical modeling, and this is where big data is making a big impact. So all these three problems and approaches were available earlier, but with the advent of big data, we are trying to get better answers to the classification problem, better answers to estimation problem, and better answers to prediction problem. So if one were to be a good big data person and be a big data project manager, you have to understand that there are these kind of problems. There are various approaches to deriving answers to these classical statistical problems. So in the next slide, I'm listing various techniques for analyzing big data. So I'm not going to get into the details because I'm I think running out of time as far as the presentation is concerned. But this is the kind of techniques that one has to master. So obviously we can't expect one person to be a master of all these techniques, but we would expect a combination of these techniques to be mastered if you had to be successful in the big data world. So there are, in terms of technologies, so we talked about techniques, various techniques and business problems and statistical problems so far. In terms of technologies, there are many options. There are open source technologies available. There are proprietary technologies. So, but essentially, one has to understand at one end the ecosystem that one has, which is around Hadoop, about distributed computing, about building a low-cost architecture which can scale out very quickly. And so that's one ecosystem that one has to be aware of. So there are various technologies there, like your Hadoop, MapReduce, Cloudera, Hortonworks, and so these are various technologies. So other end, to understand that there's a lot of databases which are a different paradigm than the relational databases. So we are talking about NoSQL databases here. So one has to be comfortable in understanding these various databases that's available. And of course, on the analytics side, we all know that the traditional database management systems are now optimized for fast aggregation, managing multiple queries and things like this, with a lot of in-memory capabilities. So there are a lot of technology trends here. There's a lot of evolution that's happening, and I have not talked about here the proprietary technologies available from your IBM or Oracle and things like this, which make big data a very fascinating world to be in. So apart from all the analytical techniques that I talked about, so the big data experts have to be comfortable with managing these various kinds of technologies as well. So moving on to the next slide, I'm coming to the end of my presentation so that we have enough time for questions. So basically, to summarize, the competency groups in big data can be on three different tracks. So one is the analytical track, where we are talking about advanced analytics and predictive modeling. So we expect people here to be comfortable in handling mathematical and statistical models, a kind of familiarity and proficiency in all statistical tools and packages. So that's one track that we're talking about. The second track is the business track, which calls for domain understanding. It could be specific subject matter expertise in, say, banking or financial services or energy and utilities. So that's a domain understanding, and also critical thinking to look at new ways of solving business problems, to unravel new data patterns and opportunities, and to have the kind of end user focus that I talked about. So the whole idea of big data is to provide a much better customer experience. So in what way can that be brought about? So that's one fundamental business driver as far as big data is concerned. So apart from the analytical track and the business track, the third track that we're talking about is the technical track. So here the challenges are in terms of how we acquire data, how we manage data. So here the challenges are in terms of integrating new data sources. So I talked about multiple data sources like your unstructured, structured, and semi-structured. So one should be able to have a kind of framework, have a kind of familiarity with bringing all these data sources together, and also to understand and manage non-traditional data. So I'm coming to the end of my presentation. So I just wanted to end with this slide, which is talking about having a competency map in place for the big data journey. So one has to start the learning curve somewhere. So we are the learning curve has to start with understanding the big data concepts, exploring the world of advanced analytics, and then learning variety of tools, which I gave a very quick overview, both open source and proprietary. And then you develop the technology competency, which is about handling all the 3 V's, understanding the big data approach, architecture, and framework. And finally, to on the business end with the business side, where we have to build domain-based solution, and which will address the problems of whether it's customer profiling or risk management or a revenue enhancement. So this is basically what I wanted to convey in my short presentation. I covered a lot of topics, but I feel I've set the context for you to kindle your interest in big data and the kind of competency challenges that we have. I am open to questions now.
Thanks for the insightful presentation. Let's quickly take up the questions now, Mr. Srinivasan. Please read out the questions and their answers so that all the users may listen to your insights. You can find the questions in the questions doc.
Yeah, I'm seeing one question which is about how should I start my journey of big data, right? So the one way to talk about it is one, of course, I mean the competency map slide that I'm on is actually the right way of starting your journey. So what one needs to do is to start with that aspect of understanding big data concepts. So you start the learning curve, and then of course you should get into the technology competency aspects and then build a domain solution. So if you also recall that I talked about 4 different stages of big data evolution. One is starting with the end user in mind, and then managing your data, and then of course building your infrastructure, ensuring that your existing data management capabilities coexist with big data, and lastly about consuming the results, ensuring that there is a culture of data-driven decision making in your organization. So that's one of the questions. So there's another question on where can I find work samples so that we can get a glimpse of working with big data. So there are many use cases. This question I understand is about how can I get more use cases as far as various big data applications are concerned. Actually, there's quite a lot of material that's available on the net. If you go to sources like TDWI, so they publish a lot of white papers and use cases, and you can also go to the sites of various business intelligence providers who actually talk about the kind of big data applications that's possible with with various kinds of tools. Okay, there are some questions about building the data management infrastructure. So again, I have to repeat my point that both relational databases and your Hadoop ecosystem, and they can coexist. So one can pull data from multiple sources and put them together. It all depends on what type of data that you're looking at. Is it structured data or is it unstructured data? So if you have a lot of structured data, you can still go with your traditional relational databases and work. But if you are looking at a lot of unstructured databases, you'll have to look at new kinds of, So there's a question on, I am a traditional developer, how can I shift to big data? So that's a good question. So obviously you will have to look at the kind of competencies that I have listed and see where you are comfortable with. What's the kind of jump that you can make as far as your technology is concerned. So you will have to make a choice in terms of which is the best option as far as all these non-traditional areas are concerned. Okay, there is a question on which are the companies today which are dealing with big data and innovating technologies. I am assuming that you're talking about companies which are actually using big data applications. So all the banks, financial services industries, essentially companies which are dealing with a vast population of customers. So companies which are facing problems in terms of segmenting customers, in profiling customers, so they're all using big data because it gives them an opportunity to look at customers in a different way. And also companies which are very active in the internet e-commerce kind of space. There's a question on what is the role of service providers in big data. I think that's a good question again, because as I pointed out, that big data is a space where a lot of aspects of technology is coming together. So it's not something which an enterprise can do independently. So they need the help of service providers to bring in capabilities specifically in technology management and in statistical modeling, and also in terms of understanding business use cases. So that's definitely a big role for service providers. And it's easier for service providers who have been earlier in the field of data warehousing to scale up and offer big data technologies on top of their traditional DW offerings. So there is a question again on will big data replace legacy ETL or BI processes? Again, I reiterate the fact that we are talking about an ecosystem where big data and ETL and BI will coexist. So plainly for the fact that there is still a lot of structured data out there in the market and out there in enterprises, and the relational database system is still the best way of handling all that structured data. So we are not talking about the demise of ETL or BI processes. So there's a question on fraudulent data. So how can big data help in looking at fraudulent behavior of customers and things like this? So my answer to this will be that if you look at the traditional fraudulent fraud detection models, they are focused on taking a few variables and trying to build some kind of statistical model which will tell what is the likelihood of fraud in a particular claim, let's say. So now with big data, actually we are trying to bring in multiple parameters. So maybe we look at the social media activity of the person who is making the claim and see the network of social media connections that the person has, and see how that fraud detection score can be enhanced. So that's one way of looking at how fraud and risk management can be done better using big data. Okay, so there is a question on the example that I provided. So it's asking about can banks use big data to answer the questions of a customer wanting to know the account balance. So the point that I was trying to make is traditional known activities such as a customer checking for his account balance, a customer wanting to make a transaction. So we are not talking about using big data here, because that's what the traditional database systems are supposed to handle. The traditional transaction-based systems are supposed to handle. So we are not replacing them with big data. So we are talking about big data providing additional inputs as far as those methods I talked about, whether it's a classification problem or an estimation problem or a prediction problem. So that's where we are bringing in the big data aspect. So there's another interesting question on will the existing reporting tools can be used in big data technology? Yes, that is happening. If you look at all the business intelligence providers in the market today, they're all enhancing their offerings from a big data perspective. So there is a big data component that is entering into all your traditional business intelligence systems. They're becoming a lot more real-time oriented, with a lot more ability to handle unstructured data. So most of the leading BI providers are definitely enhancing their tools as far as big data is concerned. There's a question on cloud. So since that's a different topic by itself, I didn't cover much on that. But we are definitely seeing a lot of big data and cloud coming together, because cloud provides a very effective means of storing a lot of high volume of data. And the only issues, of course, we'll have to overcome is that of privacy. Because in big data, we are dealing with a lot of customer data. So one has to be concerned about the way we handle privacy issues. So that's a different topic in itself. I haven't touched upon that. But one has to really look at it in a very serious way if you are looking at combining cloud and big data. So I don't expect, again the question is on, will everything move to the cloud? So at this stage I don't really expect much of data analytics to move into the cloud, but having said that, I could be wrong the way things are happening. So if data privacy and data sensitivity aspects can be handled, I see no reason why a lot of things can't be moved to the cloud. Another question on different sources of data. So there's a question about spatial data. Yes, spatial data is playing a big role in big data, especially for companies in the transportation field, companies in energy and things like this, because so we are avoiding basically the lag that was there earlier. So if you get spatial data in real time, so transportation companies are, for example, finding that they can manage their assets in a much better manner. So that's definitely the contribution of big data as far as spatial data is concerned. There's a question of what is the future of big data in India in the next few years. I would say it's really very promising and exciting, especially for many of the large organizations. In addition to that, I should say that the use of big data in social sectors like healthcare and education will definitely explode in the years to come. One knows that the field of healthcare in India, for example, is very little of data is collected. So one will see over a period of time a lot more data, a lot more unstructured data coming in to make valid predictions. So there's a question on textual data, how that can be used. As I said, that's a very important source. Today, the use of unstructured data, especially natural languages, is relatively limited compared to the use of your social media data or web data and things like this. But one can reasonably assume that this will definitely increase. So people will find out newer ways of looking at customer compliance. So what does a particular phrase mean? What are the key terms that we'll have to really monitor if to be alert to certain trends and things like this. So the use of natural language processing will definitely grow in a big way, because also about inference. So if I get let's say some social media data which is like a comment that somebody has given, how much can I infer from that comment about the person's gender, about the person's location and things like this. So there will be different approaches for that, and that will definitely see a lot of growth. So I'm coming to an end of this presentation. I want to give my final comment in the sense that we are looking at big data. Just to summarize what all I have been talking about. So we're talking about an explosive growth in big data, both at the business level and the technology level. The capabilities of big data in terms of handling large volumes of data, high variety of data, high velocity of data is continuously expanding. So at the same time, we are also seeing a lot of business problems where these explosive growth in technology will find immediate application. So I talked about few of the things, but there are a lot more applications that one can think of. For example, churn analysis in telecom companies, market basket analysis in retail organizations. So all these are areas where one will see tremendous amount of impact as far as big data is concerned. And the other aspects that I didn't touch about is the kind of social changes that can be brought about in healthcare and in education and in public policy that big data can bring about. That's a vastly different subject in itself. So thanks all of you. Thanks for patiently listening to me and posing some very interesting questions. I enjoyed talking to all of you and interacting with you through this presentation.
Yes, Mrs. Srinivasan, due to time constraint, I request you to take the unanswered questions offline, which I will share with you through email.
Sure, Aradhana. Thank you.
Okay, I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. So anything else you would like to tell our audience today?
Except that I think I covered pretty much everything that I wanted to say, except that this big data is a very vast field, so I have just touched upon, it's like a tip of the iceberg. I just talked about a few things. So those who are interested in this should delve into this both from a technology and business perspective. There are a variety of sources available for learning big data. So I'll be glad to share with them offline with people on where they can look for data, further data and insights in the area of big data.
Sure, sir. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Mr. Srinivasan, for taking time out for this webinar. Have a great evening ahead.
Thank you. Thank you. Thank you so much.
Thank you, sir.